Wow, we already learned a lot about objects. We learned 3 different ways of creating them: literal notation, new object, and object create. And you learned the important role of prototypes. You learned how to access properties of objects, how to have objects inside objects, and how to have methods on objects, so functions inside objects. You also learned that with the this keyword, you can access properties of an app object from inside of that object. That really is a lot. Now, I want to show you yet another way to create objects, and while you might think, why another way? Well, this way really makes sense and is pretty powerful. I'm talking about constructor functions. What is that? Here you go. I'm creating a constructor function here like this. I create a normal function and I'll name it person. Notice that I chose to make it start with a capital P, though that is of course my personal preference, but it's also the style you'll commonly see in the JavaScript world for constructor functions. So I have this function, and for now I'm not going to enter anything here. This might not seem super useful, but I'll extend this soon. I now create a new variable called person with a lowercase p at the beginning, and I'll set this equal to new person. That's strange. Remember that I used this with new object before? There I was using the built-in object JavaScript ships with. Here I'm building something which is called a constructor function, of which I can create new objects. This is another way JavaScript offers to create objects, and it has one big advantage which I will soon show. Now here I can set person.name equal to max, and then if I print out person, let's see what's shown in the console. I get an object with name max, so that looks exactly the same as in all the other lectures. And it is. It's just a different way to create an object. However, let's check something. If I access the proto of this object, let's see if it is equal to object.prototype. What do you think we'll see here? We get false, because the prototype probably is equal to person. Could that be? No, that's also false. So person is not the prototype. What is the prototype then? The prototype is person.prototype, as you can see here. Now we didn't create person.prototype. JavaScript kind of created it for us. As I explained, this function here is a constructor function. It's a normal function here, but we use it as a constructor function by adding the new keyword here. And this means we're constructing an object using this function here. JavaScript automatically gives us a prototype for each of our functions here, or of our objects created of this constructor functions, which we can access at person, or whatever the name of our constructor function is, dot prototype. So that is a certain prototype automatically created for us here, which we can use. And I can, for example, then say person dot prototype dot greet, and again create my greet function here, console log hello. And I would be able to call person greet here, as you will see once I hit the run button here. Hello. So now we set our own prototype and we created an object of our own constructor. So very nice. What's the advantage? We could have set our own prototype with object create. We wouldn't have that fancy person.prototype thing, but we would be able to set our own prototype anyway. So what is the advantage of this approach? Well, the advantage is if we work with this function a bit more. Currently it's empty, and therefore we can certainly discuss about its advantages. But we can configure our object here. We can use this inside here too, and for example set name equal to an empty string. Now this was used before and we used it inside an object, but it's not only available inside an object. Indeed, we can even use it outside of anything. We can just log this here too. So let's see what now shows up in the console. Well, we got quite a big object, and this actually is our window object. This is our global scope, our window object when working in a browser. This is why we have this huge thing here. So I'm just going to clear this. This simply by default refers to itself, and itself in the outer scope here, or on the top level where we can write code in the editor here, is the global object. In an object, we can refer to the object itself when using this. And here in the constructor, we're referring to our person here when using this. So if I set max here, and I get rid of max here, and I now just log out my name, what will show up in the console? Max, because I'm setting it up here in my constructor function with which I'm creating the object, and therefore I have access to this name here. Now if I go to my prototype and set up the name here too, and set it to Anna, what's going to show up now? Still max, because here I'm setting it to max. So this sets it to the object itself, whereas this sets it to the prototype. So this is not overwriting this setting here, it's setting it on a higher level to the prototype instead of the object. So here you see what constructor functions are there for. We can create our own objects, we can pre-configure them and then use this constructor to create objects based on it, to use it as such a blueprint. Like in other languages, if you are familiar with them, you could have the class keyword to create classes as blueprints, of which you can then create instances. And this is what we're doing here. We're creating a person object of this blueprint. And this blueprint still has its prototype and so on. So this prototype thing is not interfering with constructor functions. Constructor functions are just an addition to create objects. Of course, in here, I can not only set up this name, I could also set up this greet, set it equal to a function, and log something. For example, hello, I am, and then again, referring to this name to my name. If I now call person.greet, what do you think will show up if I hit run? Hello, I am Max. So I'm executing this function here, and this.name refers to the same this.name I'm setting here, so to the name of this object. Of course, if I overwrite the name here, set it equal to Anna, and I run this code, you'll see hello, I am Anna, because now I'm overwriting the name of this object. Notice though, I'm not overwriting the name of the blueprint object here, just of this instance. If I create another person, new person, and I just copy this to also greet with this person, what do you think we'll see now? We see Anna and Max. This newly created person, another person, also uses this constructor, and since I'm not overwriting the constructor here, but only this instance which was created with this instructor, this instance here doesn't care. It still uses Max from the constructor function here. And it also wouldn't care if I set person.prototype.name to Chris, for example. If I run this, we still only see Anna and Max, because the prototype is one level higher, and we're not reaching it here because JavaScript has no need to look up in a higher level, because we got name in the object itself. So what's the relation between prototypes and constructor functions? Constructor functions allow us to create objects with some default fields and values, if you want to put it like this. And prototypes allow us to inherit from objects. So they are on different levels. Whereas here, we're just providing some blueprints, which we can reuse. Prototypes are more than just blueprints. They can act as blueprints, but we always inherit them some kind of. So we're on a lower level, if you want to put it like this. If I change this function here to greet general, for example, so on the prototype here, and I now call greet general on the another person, let's see what gets printed now. Hello, I am Anna, and hello. So greet is of course still available since we have it here. But greet general is also available since it's set up in the prototype of our blueprint of our constructor function here. So the prototype of the object on which this instance here is based. Now, since I'm talking about instances all the time, JavaScript got a convenient little keyword to let us check if a certain variable is an instance of such a constructor function. I can do this by checking if person is instance of, that's the keyword, person here. Remember that when I checked if person is the prototype of this, we got false because person.prototype was the prototype. However, here, if I run this, I get true because person here is an instance of this person constructor functions. And again, constructor functions are really just helpers to allow us to create our own objects, and they ship with their own prototype on our constructor function here.